What's up, Hive? It's an amazing day today, and we're gonna make your day better. So, next on our solar series, we're gonna be talking about solar activity. So, to start us off, this video I made in the title, coronal mass ejections versus solar flares, because a lot of people get these two terms confused, and they actually don't know that they're very separate. So we're going to start off with defining a solar flare, and then defining coronal mass ejection, and then what is their difference. And then from there we're going to get deeper onto what are the effects of these two phenomena. So first, a solar flare is a release or kind of like an eruption of energy from the sun, and it is caused by back to our last video, we talked about sunspots. We talked about dense magnetic fields in those sunspots, right? Those dense magnetic fields can get tangled up. When they get tangled up, they snap. That snap releases out a burst of energy. That is a solar flare. Now, on our coronal mass ejection side, very similar story. We have this same dense magnetic field lines. Then we have it so that the magnetic field lines are so strong that they're getting farther and farther away from the sun. Finally, there's something we call magnetic reconnection. They get so far away that the magnetic field that's closer to itself, it kind of reconnects and it sends a burst of plasma and particles. So let me try to demonstrate that in a way that's more easy to understand. All right, so now we're on my whiteboard for my tablet. We're going to use yellow as the surface of the sun. So this is going to be our sun right here, right? And so on our sun, let's say that this right here is a side view, and we're gonna say that little planet that we all know and love is right here. And that, well, I probably should have done the opposite, but that's gonna be our Earth, okay? So, and this is all just for perspective. Once I finish, it'll make sense. So we're gonna use black again. This right here represents the magnetic field, and this right here, that is our sunspot right there. Okay. And for a front view, like for the front view, what we see from the Earth is this is the sun, and that's the sunspot, right? I'm just tilting it to the side. All right. So this is our magnetic field, and we have multiple magnetic field lines, right? We have some going like there, have some going right there. Let's probably put one in the middle right there, and right there. Now this is not drawn to scale. This is just for the diagram, for the sake of the diagram. All right. So what's going to happen is these magnetic field lines are going to get denser. They're going to get denser and denser. So I'm going to redraw it right here. So sun. And so they're going to get even bigger, and even bigger, and even bigger, right? Till finally they get so big that, well, first there's an understanding that you must have with these magnetic field lines. There is a positive side and there is a negative side. And so that's why I told you about the plasma, how the plasma is ions, which is just particles with a charge. So these particles, I'm going to make them orange. So these particles are following the magnetic field lines. Okay, this color differentiation is not that good. let's see if we can make it this color. Okay, there we go. So they are following these magnetic field lines, not specifically in this shape. To be honest, it's more like a helical shape. Oops. So it's like this. That's how more it is. That's more accurate of how it is. But for now, you know, it's not that important. So they're following it, right? But then this line right here, it gets so far that, you know, the positive side, the negative side right here begins to attract to the positive side right here. So what happens is they have what we call magnetic reconnection, you know? So this becomes the new path of the magnetic field line. So what happens with everything right here, it snaps and it sends off all of this energy or plasma. And so I say energy or plasma because this is pretty much the same formation for solar flares and coronal mass ejections. They're very similar. When I was doing my research for this video and I was trying to figure out what is the difference between how solar flares form and how coronal mass ejections form, it's pretty much the same thing where maybe for coronal mass ejections, for coronal mass ejections, there's actual plasma that's being followed, but for solar flares, it's just the magnetic field and it just releases energy. That's the only difference. So coronal mass ejection, there's actually plasma going around over here. Now, to kind of show it to you a little bit better, pull up this graph right here, or this picture, where again, you can see how there's the flow of the magnetic field line and how it gets so big that there's a reconnection that happens over here and the rest of the material just gets ejected. And kind of same thing that happens over here. And what's funny is this is when I searched up when I was trying to get an image for y'all, a graphic for y'all, for what a solar flare, what the magnetic field line looks for a solar flare, and this is what it looks like for a coronal mass ejection as per Google. There isn't a difference, literally same thing. So just know that solar flare, when you hear solar flare, it's only energy. When you hear coronal mass ejection, you think plasma, you think actual material. So a few other differences is that because, let's get a little bit over here, right? We'll just have right here, we're gonna add in our little diagram of the Earth. Voila. So, because a solar flare is only just energy. Energy with this color. Okay. Because it's just energy, this is gonna be a solar flare. Right here. The energy can reach the Earth really fast. Right? So maybe like max like 30 minutes or something, right? It's gonna be very quick. In comparison, a coronal mass ejection, it's gonna take a lot longer. Coronal mass ejections can last for like a week or even a month. You know, it takes a while for all that plasma to get there because of course the plasma has mass, and energy doesn't have any mass. So that's why it's moving at the speed of light, or it's moving really fast. That's another big difference between coronal mass ejections, we also call them CMEs, and our solar flares. Okay, so I opted out and added ChatGPT. And so this was the important part of the differences. So basically, how the solar flares, that magnetic reconnection that I explained right here, was the magnetic field energy being released for the solar flares, and then how in a coronal mass ejection, it's from an unstable corona. But the thing is, the unstable corona is still happening at these sunspots where there's the active region and there's still the magnetic field, and so there's still the same old magnetic field reconnection. So basically, it was basically saying how the same old, not much of a difference, at least to me. But you know, I put this source up here for you so you can judge it for yourself. But one thing I did want to note, and this is not to the title of the video, or at least what I put on the what's it called, or at least what's on the thumbnail. But this is a little bit different, but same topic. So we're going to be talking about solar activity, and so what I want to elaborate on that is that, so here we have our sun. Not everything that erupts from the sun is a coronal mass ejection. So the coronal mass ejections, those are gonna be the big parts. Those are gonna be those huge bursts of energy from the sun, right? And that come to the earth. Or those solar flares. And solar flares have different classes. X class, I believe, is the strongest one. We've had a few actually this past month. But yeah, we're not gonna be not solar flares, not the biggest ones. We have smaller eruptions where it's just very mild, just right there, or maybe right here, or maybe right there. And so we use different instruments to find them. And I'm gonna especially be talking about these smaller eruptions. It's kind of like a transition to the next solar series. But I was actually using radio telescope to look at or to find small solar eruptions based off a particular type of radio burst. But I'm gonna explain all that in my next solar video. For now, I hope you can walk out this video understanding what a solar flare is, what a coronal mass ejection is. Someone says, oh yeah, there's a CME, you understand what it is. But now, for our last part, very last part of this section, we're gonna talk about the effects of that on the Earth. So, as you can see with the diagram right here, there's been a coronal mass ejection right here, and this little wave right there, that is all the particles being sent. And right here, this is the magnetic field of the Earth, right? Now, there's something I must explain before I really get deep into that graph. Okay, and let's get our Earth back. This. And a little bit of this. Oop, there we go. Right, this is our Earth. Now, the magnetic field lines of the Earth are in a perfect circle from our, slightly tilted north, magnetic north and magnetic south, which is actually, let me, oops. Oh, how do you erase this joint? There we go. So, funny enough, the north is not is not magnetic north. Magnetic north is on the south side, but since it's on the south, all of our compasses point to the north because our compass the compass is north, right? Is our compass, is the compass north. It's gonna point to the south of the Earth, right? That's how compasses work. So this is technically the south side, but that's not important for right now. Basically, you have our north and south, and the direction, and right. So the direction is going to be from the North Pole to the South Pole of the magnet, right? So it should be from here to here, because if the Earth was a magnet, this would be its north, this would be its south. That's why what I just explained was relevant. So, right, this is a magnetic field line. It's even, it's a perfect circle and such. However, when the sun sends its plasma, it's gonna be a plasma, the plasma is now pushing on the Earth. So on this side of the magnetic field, it gets compressed. However, on this side, you had that same force pushing this side, so it's pushing it away. So what you're gonna end with is what you see on this picture right here, where the front side is very small and compact, but the back side is very long. And it's very long. And so what you see right here is the magnetic field lines coming down on this one singular point where it meets the actual pole, right? That is significant because that is the weakest part of the magnetic field. So that is where particles can sneak in right there and right there, because it's the closest part, right? This is where everything converges to. So yes, particles are able to sneak in. Now, this is just for regular space weather. Now, if there's a bigger event, it's gonna compress this Earth's magnetic field, even smaller, and that means that the particles from the sun can reach further down. But on a regular day, it's not gonna be able to reach that far because the Earth's magnetic field is further out, not as compressed. Okay. But some of the effects we get from a solar or a coronal mass ejection is an aurora. So some of those beautiful auroras you see in the the northern, southern lights or whatever. But yeah, you can see an aurora. That is because particles from the sun are hitting the Earth's atmosphere because they haven't been blocked from the Earth's magnetic field. Now, some problems that can occur is that this is what you learn in physics. This is let's say this is a wire. It's a closed wire, right? And I have a line that goes through it right here. Let's say this is a track right there. That's a track. If I have a magnet with a north and south, right? If I have a magnet and it moves through this ring where this wire is, it's going to induce a current to this wire. So a changing magnetic field causes a current, right? Now, what does that mean for the Earth? Well, my Earth is just now going to be this right here. This is my Earth. Magnetic field lines start from here, right? And then they change to here, right? Oops, wrong color. Change from here, where it's compressed. That is a lot longer, right? Well, this is a change in the magnetic field. So it's going to induce a current. And we know that the Earth has a rock core, a metal core, so it's going to cause a current to the Earth. And this is where we're seeing our generator meltdowns, and our pipe erosions. Because what's happening is, we have these pipes that are going from Alaska all the way to, North America. this is basically like a one long wire, and it can corrode, not erosion is like geology or something. It corrodes because there's a current going through the wire, and that current can heat up the oil, and the oil then corrodes the metal pipe. So those are just two problems. You know, with solar flares, it gets a little bit different. Solar flares can cause a lot of background noise in communications. And can just make, that's probably the biggest, that's the biggest effect, honestly. Oh, and I'm missing a big effect. I'm missing a big effect on the coronal mass ejection. So, let's see, where should we go? We'll go right over here. Perfect. So we have the CME, we have all these particles right here. Now, let's say I draw a little dude right here. Boom, boom, bam, bam. Nice little helmet. That's astronaut. And let's say I draw this right there. Draw little lines. Whoops. Okay, draw little lines. Little box right there. Circle right there. That's gonna be my satellite. So what ends up happening is during this little coronal mass ejection, this astronaut just gets bombarded with all these particles, right? And so what can happen is if you zoom in on the satellite, you know, you go into the inner wiring. So these are my wires, my satellite. It's my little circuit board. So you get the circuit board's usually green. This is my circuit board. Well, what can happen is now a particle hits the circuit board and it can flip a switch. It flip a bit, turning something off. Or it can burn something where now you have a short circuit. So now your wiring is damaged and your satellite isn't working anymore. That's the first problem. Now let's zoom in on this astronaut. Well, in the astronaut, what do we all have? What do all humans have? We have a little thing called, I'm trying to draw a little double helix. We have DNA. And so this particle is coming. It can hit and damage the DNA, giving our astronauts a higher chance of having cancer. So that is another very big, very major effect of coronal mass ejections and solar flares. So now, at this point of the video, y'all should be coming out, because this is the end of this one episode. It's probably a long one too. But y'all should be coming out knowing the difference between coronal mass ejections and solar flares, knowing what they are separately, knowing how there's a lot of activity going around on the sun, and knowing what effects that this solar activity has on the Earth and how it can affect you. So that's gonna be it for the video. As I said, hope you enjoyed it. If you did, give it a like, and go ahead and subscribe if you're not. If you didn't enjoy the video, give it a like and subscribe. If you have anything on your mind that you want to ask, any questions, go ahead and put that in the comments, and I will respond to the comments, answering what I can. Of course, like always, I'm going to have my sources there, so if you want to look up some information on yourself, feel free to start with the sources I already have. And that's going to be it. We're going to be out.